Today, I'm going to share with you all of the shapes that I learned from before I started pre-K to the 12th grade. We will start by looking at one-dimensional shapes.
A line is any straight object that goes in between and beyond 2 points. There are many different types. A whole line, which goes on forever in both directions. A ray, which starts at one end, and goes on forever in one direction. A line segment, which doesn't go on forever. It is a part of a line with two endpoints. Parallel lines, which never cross. Intersecting lines, which do cross at a point, and perpendicular lines, which form right angles, which are angles that are 90 degrees in measure. A curve, which is any line that is not straight. A parabola, which is mere or symmetrical U-shaped curve. And an arc, which is part of the circumference, the edge of a circle.
Now we have some two-dimensional shapes. They have two dimensions, length and width, but no height.
A polygon is a closed shape made up of many connecting line segments. Polygons are named by the number of sides they have. Poly means many, gon means angles. Polygon comes from the Latin or Greek term meaning many angles. A triangle is a polygon that has 3 sides. Tri means 3. There are 2 ways to classify triangles. You can classify triangles by the lengths of their sides, and you can also classify them by the measures of their angles. Let's start by classifying triangles by the lengths of their sides. There are 3 possibilities. An equilateral triangle is in which all of its sides are of equal length. If that's the case, all of its angles have to be of equal measures, that is that each angle has to be 60 degrees in measure. An isosceles triangle is in which 2 of its sides are of equal length, and a scalene triangle is in which all of its sides are of unequal length. Triangles can also be classified by the measures of their angles. Each triangle has at least 2 acute angles, and the third angle determines its name. Speaking of angles, remember that an angle whose measure is exactly 90 degrees is called an right angle. An angle that is greater than 90 degrees but less than 180 degrees in measure is called an obtuse angle. And an angle that is less than 90 degrees in measure is called an acute angle, where obtuse means wide and acute means sharp. With those angles known, a triangle with a right angle is a right triangle, a triangle with an obtuse angle is an obtuse triangle, and a triangle whose angles are all acute is an acute triangle. A polygon that has 4 sides is called a quadrilateral. Quad means 4. There are many different types. A square, in which all of its sides and angles are equal. The angles are in fact right angles. A rectangle, in which all of its angles are right. A rhombus, in which all of its sides are equal. That doesn't mean all of its angles have to be right angles. A parallelogram, which has 2 pairs of parallel sides, opposite sides of which are equal. A trapezoid, which has only 1 pair of parallel sides. That's what it's called in the US, but it's always called a trapezium in the UK. An isosceles trapezoid as it's called in the US, or an isosceles trapezium in the UK, which is a trapezoid in which its non-parallel sides are of equal length, and a kite, which has 2 pairs of equal adjacent sides. What would you call a quadrilateral with no pairs of parallel sides? A quadrilateral with no pairs of parallel sides can be called a trapezium in the United States if it's convex, or an irregular quadrilateral in the United Kingdom. Otherwise it's not necessary to give it a special name. So it can just be called a quadrilateral. With polygons that have anywhere from 5 to 10 sides, the name will be made by combining one Greek-derived numerical prefix with the suffix gon. A polygon with 5 sides is a pentagon. A polygon with 6 sides is called a hexagon. Hexa means 6, and in hexa and 6 is an X, which is something to think about if you want to remember that shape. A polygon with 7 sides is a heptagon, also called a septagon. A polygon with 8 sides is called an octagon, where octa means 8, as seen from an octopus, which has 8 legs, which is something to think about if you want to remember that shape. A polygon with 9 sides is a nonagon, and a polygon with 10 sides is a decagon. Polygons with more than 10 sides will combine 2 or more Greek-derived numerical prefixes with the suffix gon. With the special names used, a polygon with 11 sides is called a hendecagon. That's 1 plus 10. A polygon with 12 sides is called a dodecagon. That's 2 plus 10. A 13-sided polygon is called a tridecagon. That's 3 plus 10. A 14-sided polygon is called a tetradecagon. That's 4 plus 10. A 15-sided polygon is called a pentadecagon. That's 5 plus 10. A 16-sided polygon is called a hexadecagon. That's 6 plus 10. A 17-sided polygon is called a heptadecagon. That's 7 plus 10. An 18-sided polygon is called an octadecagon. That's 8 plus 10. A 19-sided polygon is called an anidecagon. That's 9 plus 10. And a 20-sided polygon is called an icosagon. Otherwise, with a polygon with more than 12 sides, you can just call it an n-gon, where n represents any number. For example, a 24-sided polygon can be called a 24gon, a 48-sided polygon can be called a 48gon, and so on. Polygons are regular when all of their sides are of equal length, and all of their angles are of equal measures. Otherwise, polygons are irregular when not all of their sides are of equal length, and not all of their angles are of equal measures. A star polygon is a non-convex self-intersecting regular polygon. In a similar way, star polygons are named by the number of points formed by the interesting edges. A 5-pointed star is called a pentagram, a 6-pointed star is a hexagram, a 7-pointed star is a heptagram, an 8-pointed star is an octagram, a 9-pointed star is an enneagram, a 10-pointed star is a decagram. Not the metric unit of mass or weight. An 11-pointed star is a hendecagram, and a 12-pointed star is a dodecagram. And lastly, we have some shapes that are not polygons because they have at least one curved line. A circle, which is a closed curve consisting of points that are equidistant from the center, some parts of a circle, a sector, which is enclosed by an arc and two radii like a pizza slice. The radius is the line segment that runs from the center to any point on the circle. A circular segment, which is enclosed by an arc and a chord. A chord is the line segment that connects any 2 points on the circle. A semicircle, which is half of a circle and a sector that has a 180 degrees central angle. Its endpoints lie on the diameter. An annulus, which is a plane ring shape made up of 2 concentric circles. An oval, which is a closed curve that looks like an egg. An ellipse, which is a special oval surrounding 2 focal points, such that the sum of the distance between them is constant. It is usually like a flattened circle. A lens, which is a shape made up of 2 arcs joined to each other at their endpoints. It is like a pointed oval. A crescent, which is the shape of the waning or waxing moon. A quatrefoil, which has 4 lobes. Think about the lobes as the roundish parts of something, like this shape. And a heart, like the organ of your body.
And lastly, we have some three-dimensional shapes. They have 3 dimensions: length, width, and height.
Polyhedra are 3-dimensional shapes that have many flat polygonal faces. Poly means many, hedron means faces. A prism is a type of polyhedron. Prisms have 2 congruent bases that are polygons, and lateral faces that are parallelograms, or they would be rectangles in the case of a right prism. We name prisms by the shape of the bases. So to name a prism, look at the bases, and those determine its name. For example, a prism with triangular bases would be called a triangular prism, a prism with hexagonal bases would be called a hexagonal prism, and so on. A parallelepiped is a prism whose bases are parallelograms, and so all of the faces would be parallelograms. A prism can either be right or oblique. A right prism is when the bases are perpendicular to each other, leaving all of the lateral faces to always be rectangles. Otherwise, a prism is oblique, when the bases are not perpendicular to each other, thus not all of the lateral faces are rectangles. A pyramid is a 3-dimensional shape that has a single polygonal base, and triangular lateral faces meeting at a vertex at the top, known as the apex. Pyramids are also named by the shape of the base. So to name a pyramid, look at the base and identify it. That will determine its name. For example, a pyramid with a rectangular base would be called a rectangular pyramid. A pyramid with a hexagonal base would be called a hexagonal pyramid, and so on. As with prisms, a pyramid can be right or oblique. A right pyramid is when the apex is directly above the center of the base. Otherwise, if the apex is not directly above the center of the base, the pyramid is oblique. A truncated pyramid is a pyramid with its apex cut off by a plane. These next polyhedra are regular. If that's the case, all of the faces have to be congruent regular polygons, and all of the vertices are congruent, that is, the same number of faces meet at each vertex no matter which way you turn the shape. The 5 convex polyhedra were described by an ancient Greek philosopher named Plato. After which, they are the Platonic solids. The tetrahedron, also called a triangular pyramid, which has 4 faces that are all triangles, 3 triangles meeting at each vertex. Tetra means 4. The one shown is a regular tetrahedron, which has equilateral triangles for each face. The cube, which has 6 faces, each face a square, 3 squares meeting at each vertex. Because a cube has 6 faces, it's a hexahedron. That doesn't mean all hexahedra are cubes. But that's because the one shown is regular. The octahedron, which has 8 faces. If it's regular, each face would be an equilateral triangle, 4 triangles meeting at each vertex. Octa means 8. The dodecahedron, which has 12 faces. If it's regular, each face would be a pentagon, 3 pentagons meeting at each vertex. Dodeca means 12. And the icosahedron, which has 20 faces. If it's regular, each face would be an equilateral triangle, 5 triangles meeting at each vertex. Icosa means 20. If you take any of the 5 Platonic solids and either cut off all of their vertices, expand or snubify them in any way, you'll get the Archimedean solids. The truncated icosahedron is the best example because it has been seen many times since it's usually used for soccer balls. Another example is the truncated cube, obtained by taking a cube and cutting off the original vertices. It's made up of 8 triangles and 6 squares. Those are 2 of the 13 examples of the Archimedean solids. Lastly, we have some 3-dimensional shapes that are not polyhedron because they have at least one curved surface. A cylinder, which is similar to a prism, but not technically a prism because it has 2 congruent, usually circular bases, and a curved surface. A cone, which is similar to a pyramid, but not technically a pyramid because it has one, usually circular base and a curved surface that meets at a point at the top, known as the apex. A truncated cone, which is a cone with its apex cut off by a plane. A sphere, which is a round shape like a ball, in which all points on its surface are equidistant from the center. A hemisphere, which is half of a sphere. An ellipsoid, which is a surface that has cross-sections that are all ellipses. It is usually like a scaled sphere. And a torus, which looks like a donut.